In this video, we're going to learn how to convert from polar to rectangular coordinates. So, if we were given a point r theta, it can equal a particular point xy by plugging in r and theta into this formula for x, which is r cosine of theta, and r and theta into this formula for y, which is r sine theta. We can find that rectangular coordinate. Now, let me quickly go over why this formula is the way it is. If, for example, r was equal to 0, regardless of the angle, the point is just the pole. So in this case, for rectangular coordinates, that would be 0, 0, if r is equal to 0. But if r is a positive radius, if I were to drop a vertical right here, the change along the side would be x, and the vertical change upwards is just y. So I can say that cosine of that angle theta in between is equal to adjacent over hypotenuse, which would be x over r, leading me to have x is just equal to r cosine of theta. And same thing with sine of theta. That's opposite over hypotenuse. That'd be y over r. So y would just equal r sine of theta. But now, what happens if that radius happens to be negative? Well, if I want to represent the same points, if I'm using negative r, then I need to think of what point I have over here so I can do the negative radius back. So to get that angle all the way out here, I need to add another pi rotation. So that point would be negative r comma theta plus pi. So I can use the negative radius to go back to the same points. So down here I can represent that same point as negative r comma theta plus pi. So in this case, I can say that cosine of theta plus pi is equal to, again, I need to drop my vertical here. I can use that reference angle, but it'll be that angle. Theta plus pi is equal to to x over negative r. And sine of theta plus pi is equal to y over negative r, opposite over hypotenuse. But what is cosine of theta plus pi equal to? If I use the sum formula for cosine, which would be cosine of theta times cosine of pi minus sine of theta sine of pi, I can get cosine times negative 1, which is negative cosine of theta, minus sine times sine of pi, which is 0. It's equal to x over negative r. And if I were to solve this for x, x would still equal r cosine of theta, which is a good sign, so I don't have to use a different formula depending on the radius. Use the same formula either way. And over here, I can do a very similar setup. I can say that sine of theta times cosine of pi plus cosine of theta times sine of pi is equal to y over negative r, using the sum formula for sine. Again, cosine of pi is negative 1, so I get negative sine of theta plus 0, because sine of pi is 0, is equal to y over negative r. And again, y would just equal r sine of theta. So either way, no matter what the radius is, I can use this formula. Even up here, if r was 0, that would be 0 times cosine, so it would be x is equal to 0 and y is equal to 0. So I can use these formulas no matter what the radius is and no matter what the angle is. So let's put this into practice. So let's say I want to Find the rectangular coordinates for this point 6 pi over 6. So pi over 6 is this angle right here, and 6 would be 1, 2, 3, 4, 5, 6 out from it. And now I want to find the rectangular coordinates, meaning how far out and how far up does it go? What are the x, y coordinates for it? So to find the x coordinate, I'll use 6 cosine of pi over 6, which would give me 6 times the square root of 3 over 2. So x is equal to 6 divided by 2, 3 square roots of 3. Y, on the other hand, would be equal to 6 times sine of pi over 6, which is 1/2. So 6 times 1/2 is 3. So the rectangular coordinates would be 3 square roots of 3, comma 3, which means that it goes up 3, if I'm thinking rectangular coordinates, 1, 2, 3, and over 3 square roots of 3 along the x-axis. And I might need to go down a little bit more right there, but 3 square roots of 3 is a little bit more than 5, so a little bit more over here. You'll see it's just past the radius of 5 there. Now let's try another example. Now we have a negative radius. So if I have negative pi over 4, which is rotating downwards 3 tick marks, it's a negative pi over 4. And then negative radius means doubling back. So 1, 2, 3, 4. That's where my point would be. Now I know my point's in the second quadrant, so I should have a negative x value when I do this. X will equal negative 4 times cosine of negative pi over 4, which since cosine is even, I can write that as negative 4 times cosine of positive pi over 4 without having to take out the negative, just get rid of it, which gives me negative 4 times the square root of 2 over 2, which gives me negative 2 square roots of 2 for x. Y, on the other hand, would be negative 4 times sine of negative pi over 4, which I can factor out that negative because this sine's an odd function, give me positive 4 sine of pi over 4. So y is equal to 4 times square root of 2 over 2, giving y the value 2 square roots of 2. So the rectangular coordinates would be negative 2 square roots of 2, comma 2 square roots of 2, which makes sense that x is negative. And if I were to drop that vertical down, this value is probably around 3-ish for both, maybe a little bit more. What is 2 square roots of 2? A little bit less than 3-ish, probably just on the inside of this radii, but for the rectangular coordinates in that space. Now let's say we have a radius of 5.5 and an angle of 110. Now these do rotate by 15 degrees each for the graphs I have here. So if this is 90 at the very top, this next one here would be 105. And the following one would be 120 degrees. So 110 is in between these two. And 5.5 would be between 5 and 6. So that point would be about right here in space. Its rotation. And the x-coordinate would be 5.5 times cosine of 110 degrees, which 110 is not a unit circle value, so I don't know its exact value, but I can just type in 5.5 cosine of 110, which makes sure your calculator is in degree mode before you hit enter. So x is about negative 1.88, and the y is equal to 5.5 times sine of 110. So y is approximately 5.17. So that coordinate would be negative 1.88, comma 5.17. We are in the second quadrant, and if I were to drop a vertical from that point to the x-axis, it is just a little bit inside the radius of 2. If I drop a perpendicular from the point to the y-axis, is just past 5, so 5.17. That does make sense for the answer. And that is how you convert from polar to rectangular coordinates.